Good morning, everybody. So now you can see here, question number 15. Manju has two convex lenses, P and Q, made of same material as shown in the figure. But of course, if you see these figures immediately, forget about the questions. You might be getting something. Can you tell me what is that? One is thicker, another one is what, guys?
No.
Thinner.
No.
That is the thing. It should be coming to our mind. So now she is looking at printed text on a page using lens P. She noticed that when she slowly takes the lens away from the page, the text turns upside down when the lens crosses a distance of 10 centimeter from the page. So means in the sense of, anybody can guess what is the focal length of the lens? Less than 10 or greater than 10 or equals to 10. See that, observe. So definitely it will
Equals to 10.
be equals to 10.
10.
Correct or not? The focal length of the lens, maybe it is less than 10 or equals to 10. We cannot, because when she is seeing with the help of the P lens, observe very carefully all of you. So as we know, it is a convex lens. So we can use it as a magnifying glass also. When we place the object between, imagine this is a convex lens. So only it will work as it will form a virtual and magnified image only in one case. Anybody can tell what is that case? When the object is placed between the optical center and principal focus. Sorry, anyhow, F1. So now this side or this side, whatever it is. Now if the object will go in between F1 and optical center, it will form a virtual image and magnified image. So that is what we will use to read the text. Now they are saying that whenever she moving away from taking the lens away from the page more than 10 centimeter, means she went more than 10 centimeter, so that what is happening, suddenly images are turned into upside down, means they will become what? Real
image.
Inverted. So means in the sense of the object is went behind the F1. Is it right or wrong? Will you all accept it? Please, everybody. So that is what you have to remember. So the focal length of the lens, maybe it is a 10 centimeter, or if it is less than 10, that's fine. Now, they are asking which characteristics of lens P does the distance 10 centimeters signify? Anybody can tell? 10 centimeters signify. Just now we said, what is that it will signify?
Focus.
Yes, everybody. It is signifying what? You have
Principal
to
focus.
answer. It is signifying. Yes.
Principal focus.
Principal focus. That is what you have to remember. So as it is we can find the focal length or principal focus. So what is the focal length of that? Without reading question, you see that is the gate. We are going to the concept. Later the questions will be very easy. So now focal length we can identify, or we will find the principal focus. Is it right or wrong? Principal focus. So principal focus means focal length only we can find, which is F. That's fine. Very good. Over. Next, if Manju does the same with the lens Q, at what distance will the inversion of the image happens? Inversion of the image happens less than or equals to or more than 10 centimeter. Justify your answer. So for this question, so observe very carefully. You might be having an idea that thickness is less, focal length is more. Thickness is more, focal length is less. Of course, if it is the same material, it doesn't matter. Do you remember the human eye? Do you remember the human eye? When we are seeing the near objects, the thickness is more. Near objects, thickness is more. Ciliary muscles will get relaxed. Relaxed or contraction? Anybody?
Relaxed.
Relaxed or not? When we are seeing the near objects. When we are seeing the near objects, thickness should be maximum. Yes, Elmokil, contraction or relaxation?
Contraction.
Contraction. So the thickness is maximum when we are seeing the near objects. So focal length is decreases, power is increasing. Now when we are seeing the far objects, low power is needed, low converging power. So ciliary muscles will relax, thickness will be decreases. Thickness will be decreases means focal length is increasing and who is decreasing? Everybody. Yes, please. Focal length is increasing, so who is decreasing? Power is decreasing. Now observe very carefully, same material doesn't matter. Now here thickness is less, so I can say focal length is more. Now here thickness is more, so that what will happen? Anybody can tell focal length what will happen?
Decreases.
Focal length less, sir.
Yes. Less.
Focal length decreases.
Yes.
than 10.
So now tell me, thickness is more, means focal length is less. So focal length definitely will be how much? Less than 10 or equals to 10 or more than 10? Anybody? Check it.
Less than 10.
Less than 10.
Both are same material. So it is thinner, it is thicker. So definitely what is your answer? It will be
Less than 10.
all of you. The focal length is less than 10 centimeter. What is the reason behind? Thickness. You have to write that. Understand? The thicker lens has small focal length. Or thickness is inversely proportional to focal length. That is the statement we put. Are you clear, everybody? This is the concept you should solve from the human eye. So when we are seeing the far objects, when we are seeing the near objects, how the focal length is varying our human eye. The same concept is applicable as it is made with the same material. Okay. So 2 points you should remember here. Focal length is increases, power decreases. Focal length is decreasing, power increases, but that is related to power and focal length. Now thickness. Thickness is greater, focal length is less. For thickness is lesser, focal length is higher. Please note it down. That is why when we are seeing the far objects, we need low converging power or high converging power. Anybody?
Low converging power.
Low converging power. So the lens should be thicker or thinner? Sorry, I made here mistake. The lens should be thicker or thinner? All of you, when we are seeing the objects, the lens should be thinner so that the power will be, the lens should be thinner so that focal length is maximum. So power should be what? Power should be minimum. Is it yes or no? So when we are seeing the near objects, the thickness should be maximum, means focal length is minimum, but who will be maximum? Power is maximum. Understand? So that is why when we are seeing the near objects, high converging power is needed. That is you have to remember. Anyhow, thickness increases, focal length is decreases. That is what you have to remember. So what is the answer for this? Less than 10. Okay, and you have to write the answer. Focal length is inversely proportional to thickness of the lens. That is the answer. Clear, everybody? Please respond. Okay, next.
Yes, sir.
Any doubt, anybody, please ask. Now, next question. Next question, I don't want to read also. By seeing the power minus, I can say it is a myopia or hypermetropia. Anybody?
Myopia.
Myopia.
Myopia. Because power is minus, means concave or convex lens.
Concave.
It is a concave lens. That's all very clear. Okay. So myopia also we can say nearsightedness, or we can say what sightedness? Short-sightedness. Okay. Now, what is the possible vision defect of the person? Over already. What is the answer? Myopia. What is the focal length of the corrective lens? What is the focal length? Find it. They have given dioptries. You can find it directly. Focal length is equals to, all of you, 100 divided by P, because we want in centimeters. So 100 divided by minus 5 dioptries, which is equals how much will come? Yes, please. Somebody?
Minus 20.
Minus, how much I?
Minus 20 centimeters.
Yes, minus 20 centimeters. Okay. Now, or else I can use focal length is equals to 1 by P. So, which is equals to 1 divided by minus 5. So, which is equals to how much? 0.2 centimeter. Minus 0.2 meters. So, whatever it is, both are correct. Your choice. You can solve. Please solve it. Anyone is having doubt? You ask. Clear? Minus, Ramanujan, minus is very important because power is minus and focal length also minus. Because what is the lens we are using? What is the lens we are using, guys? Here connecting?
Concave.
Concave lens. That is very important for me. So that is what you have to remember. Do it now. No need to write the question. Then mark the question and solve. Everyone should try. Next. Refractor index question. So now, a lens made of material with refractor index 1.5 immersed in a liquid with refractor index 1.5. Refractor index of lens also 1.5, immersed in a liquid with refractor index 1.5. Now the diagram below shows two rays incident on the lens when it is immersed in the liquid. Now, liquid of refractor index is also 1.5 and refractor index of material also 1.5. Now, copy the diagram and draw the light rays after they pass through the lens. Justify your answer. Anybody? Just to check it, I taught you the one concept, remember, forgot about here water or material or whatever it is. Let me take two mediums, look into the picture. Let me take, this is the two mediums, okay, and this is the another one medium. This is one medium and I'll take another one medium. So whatever it is doesn't matter. That middle point, what I called yesterday also I told you during the revision time, that middle part, intersection part of two mediums, what is to call? Anyone? Interface.
Interface.
So now, when the light is entering from one medium to another medium, of course, if it will, even though they are having a different refractive index, of course, they mentioned here, refractive index is what? Refractive index is what? Same. Is it yes or no? So now refractive index is equal means light will travel with the same speed or different speed?
Same speed.
Same speed. So light will go without deviation. Do you remember that? Even though I inserted obliquely, light will go with deviation or without deviation. I want response from you all of you. No refraction will take place. Is it right or wrong? Please respond. Yes, no refraction because refractive index is equal. So here, same ray diagram you draw, take your scale and you just draw. What will do? It is entering from water, liquid to substance. So what will happen? All of you. It will go in a, nobody is answering. It will go in a what?
Straight line.
Straight line. That's all. So what is the answer you should mention? Yes, please. Here only answer. What is that answer? If the refractive index is same, then what will happen? No refraction will take place. That's all. If any mediums having the same refractive index, then no refraction will take place. That is the statement you have tried. Mr. Narayan, have you understand? Mr. Adarshan, please be very active and you have to answer the such an important question. See that how thinking, unless you are having a mind, you will never answer the questions. Very simple concept. Now, one more thing is there. Even though different refractive index, but still no refraction will take place. Anybody tell me the case? Girls, Alana, Durga, even though two different refractive index, but still it will take, no refraction will take place. Anybody? Very good. So let me take, this is the one medium and this is the another medium and this is what interface. Remember where the refraction will take place? Only at the, where the refraction will take place, everybody?
At the interface.
At the interface only. So both are transparent medium. This is refractive index is something, this is refractive index is some other thing. So refractive index of medium 1 is not equals to refractive index of medium 2, but still no refraction will take place in particular case. What is that case? All of you, no refraction when a light is inserted perpendicularly to the surface. Understanding? So light ray will go in a straight line. This is also one of the case which I taught you very specifically. But now this is the case what they are giving. Even though two different mediums, one is liquid medium, you can check it here. One is liquid medium and another one is material, glass lens material. So both are different, but what is the common thing here? You have to notice it. What is the common thing? Their refractive index is remains same. So refractive index of lens, which is equals to refractive index of liquid. Okay, so that no refraction will take place. Are you clear, guys? Please respond. Very, very important. So you take the scale, draw the same diagram, draw a straight line kindly. I might be, my diagram may not proper. You must draw a straight line. Please draw it perfectly. Any doubt? Anybody can ask. Clear, guys? Yes, please. Mukil, Kevin?
Yes, sir.
Okay, now completed. Next, 17th question over. Any doubt, girls, boys? Joel, Sai, Mavanish? Anyone of you are having doubt? Please let me know. Clear, guys? No. Right. Over. Next question. Try, please try. If you are sitting and waiting for my answer, you will never get. How the people are solving same way. This question you people easily can solve. Nothing needed. Let me see. Don't say the answer. I will ask somebody. Let me see who will say. Yes, please. You proceed. Read everybody. Two more question it is. Mind, you must have more proper imagination. Otherwise, you people cannot solve. Yes, please. Two more question it is. Be very careful and solve it. Mr. Kadri, I have given you number correct, but you not join with the number. Murali, your number is 25, Murali, you are not 24. Ganesh also, your number is 31, Mr. Ganesh. Okay, so please make it now. So observe this question. Read the question, everybody. The images below shows the refraction of light in three different transparent rectangular blocks X, Y, Z made of different materials when they are placed in air. The angle of incident is different in each case, but the angle of refraction is the same in all the three blocks. So notice it very carefully. Angle of refraction, let me take, you can see. They are saying that angle of refraction is same, but who is not same? Everybody? Who is not same? Angle of incident is not same. Now, forget about this one, the statement which they have given. Notice it. Which angle is bigger? Angle 1, angle incident, angle 1, 2 or 3. Which is bigger for you? Looks what? Who is greater? Angle 3 is greater compared to angle 2 and angle 1 is smaller. Is it yes or no? All of you?
Yes, sir.
Yes. So that is what they're saying. So incident angle 3 is greater than incident angle 2 greater than incident angle 1. But they're saying that all the refracted angles are what? All the refracted angles are what? Same. Now let me go to the question, what they're asking. Compare the speed of light in 3 blocks. Justify your answer. Now can you tell me in which block the speed of light is maximum? Anybody?
X.
Yes. Why? Anybody?
Bending is less.
Bending is less. That is what you have to remember. So, point you should remember here, the concept behind is, as we all studied, incident angle increases. Bending should be what? Bending should be also displaced. Deviation is also what? Increases. Yes or no? All of you? Please respond. That is. So, when you notice it very carefully, if the greater the incident angle, then higher will be the bending of light. That is what we studied. Do you remember or not?
Yes, sir.
Yes.
So, all of you should remember, whenever if the incident angle is greater, but if the same refractive index is showing in all, angle of refraction remains constant. So, in this case, note the statement that speed of light is inversely proportional to, even though different mediums, in this case alone, speed of light is inversely proportional to, okay, angle of incident. So angle of incident is greater, speed of light is less. Speed of light is greater, angle of incident is less. Now tell me in which medium it is. Compare the 3 mediums and tell me in which medium it is greater. All of you. Check it and tell me. In which medium light is traveling faster? Everybody. X. Next medium what? Y. Next medium what? Z. So I will say, what is the answer will come? In speed in X is greater than Y is greater than Z. That is your answer. So remember, incident angle is increases. Even though the refraction is showing, the angle of refraction remains constant, but what about the speed variation? If the incident angle is greater, the speed of light is less. That is you have to remember. In a different material, but they are showing the same angle of refraction. So that is what it is. Clear, everybody? Note down the statements that this is the case. You have to remember it. Now, all of you observe very carefully. Next, what is the relationship between speed and refractive index? All of you. Speed and refractive index.
Inversely proportional.
Speed and refractive index is inversely proportional. Okay. Now, sir, if I am not familiar with the angle of incident and speed of light, you go with this one also. So according to the Snell's law, observe very carefully. Snell's law, check it and tell me, what is the Snell's law, all of you?
Sin A by sin R.
Sin A by sin R equal to
Refractive index or constant is equals to, what is that? Sin I divided by sin R. Is it yes or no? So now, if we'll take it here, the angle of incident is minimum, then you can see the refractive index is also minimum, because here, what is the relationship between N and I, refractive index and the angle of incident? Yesterday I told you in our school class. Yesterday I told you in our school class, incident angle varies from where to where? Everybody.
0 to 90.
0 to 90, very, very important. Do you understand, everybody? Now, you tell me, if angle of incident is less, refractive index is also what? Less or more? Because refractive index is directly proportional to angle of incident. You understand, Elmukil, Kevin? Everybody,
Yes,
now tell me, refractive index is less. Sorry, incident angle is less. Means refractive index is also what?
less.
Less. Now, if refractive index is less, then what about the speed relation? Speed relation
More.
inversely proportional to. So speed is maximum. So now you tell me, in which medium speed is greater? All of you. Yes, please. In which medium speed is
X.
greater? X, Y, Z? X. Understanding? Because here angle of incident is less, so that refractive index is also less. So who will maximum? Speed is maximum. Clear, all of you? Others, anybody is having any doubt? Please ask me. Pradeep, Rohit. So here two statements you should remember. According to the Snell's law, refractive index is directly proportional to angle of incident. So it will be varies from 0 to 90 degrees, the most important one. Okay, so angle of incident is less, refractive index is also less. If refractive index is less, then who is more? Speed is greater. Okay, or velocity of the light is greater. So here incident angle is less, so refractive index is less, so speed is more. Okay, so you put the statement here. In exam also, like this mathematical way you write, so that you'll be awarded complete mark. That is what my suggestion. Any doubt, Mr. Monish, Aswita, Manya, Alana? That is. So you want, you can write the answer also. Okay. So according to the Snell's law, angle of incident and refractive index is directly proportional to each other. Angle of incident and refractive index is directly proportional to each other. Since the angle of incident is minimum in block X, okay, block X. So the speed of light is maximum in block X. Clear, everybody? All of you? Please respond.
Yes, sir.
Yes, sir.
From this you can say which is optically denser medium. Anybody? That is also I'll ask you. Can you tell me which is optically denser medium? X. Optically denser medium. This is optically denser medium. This is also one of the questions. Add down. Optically denser medium. Because high refractive index or low refractive index. Refractive index is maximum. Do you understand it? Next, which is the rarer medium? Everybody? Try to answer. Durga, which is the denser, rarer medium?
X.
X.
This is the optically rarer medium. Because why? Refractive index is minimum. So please, below this question, you add our own questions. Instantly we are forming which is optically denser, which is optically rarer. So please make it clear, all of you. Now meeting is going to end. I want to see everybody join back because every question is unique style. We have to solve everybody's progress. Now we don't have. Now you can check it. This is what about the light chapter. Totally how many questions? 18 questions. No question we left except 14 questions. That is also we solved. But still I want to make you the answer. Now if you'll notice, so here every question we did 100% perfectly. So here some answers are mistake. This is the answer is wrong. So which is not 18.6 mm, which is how much Elmukel? Pradosh? I think 15.6 mm. But the thing is no explanation. Those who will copy from the book, nothing will get further. You might be you felt what is the difficulty when we are solving. So when we are solving only we'll feel the difficulty. Next same way, this question, it will come only 3 centimeter. Okay, it's not 3.6, it will come 3 centimeter. That is also you have to remember. So on the different, what is the length of that one? because we will get 4.5 centimeter. So 7.5 minus 4.5, we will get how much? It is only 3 centimeter. So when we are solving only, it will come. This is only 14th question. So we have to solve it very carefully. Of course, we will solve, no issues. So don't worry. Once again, I will solve it and send. So other than this, there is no question which we left. So I think this is the ray diagram you can see. It will just go in a straight line. So whatever it is, for example, they will give you like this, guys. Now tell me how it will happen. Suppose the light ray is coming from like this. Now tell me what will happen. Now also what will happen? Yes, please. Now also they will go in a refractive index is same means what will happen? They will go in a
straight line.
Straight line. That you have to remember. Whatever it is, for example, they have given from this point. Okay, doesn't matter wherever it is. So it will go in a what?
Straight line.
Okay, Mr. Sai. So that is you have to remember. So if the refractive index is same or the light is inserted perpendicularly, always no refraction will take place.